All right, everyone. Today we're looking at our graphs of sine functions and cosine functions, as well as some basic transformations. We will be continuing this throughout the week, so please be mindful of your notes. First things first, graphing our sine function. As you may recall, our sine functions are essentially going to be the y-coordinates of our unit circle, such that if we're going from 0 all the way around for one rotation, we're looking at essentially the y-coordinates, 0 towards the 1, towards the -1, so on and so forth. In terms of our actual graph, our x-coordinates here, our x-axis, is not going to be based off of the normal 1, 2, 3, 4, 5, or negatives, or so on and so forth, but rather based on the radians. So here at the origin, we have 0 pi, outward for one rotation, 2 pi, halfway between them, pi. Between 0 pi and pi, we've got pi over 2. And then between pi and 2 pi, we have 3 pi over 2. This essentially makes up one period, one rotation. So if we were to graph this out, at 0 pi, our sine is 0. At pi over 2, our sine is 1. At pi, 0. 3 pi over 2, -1. At 2 pi, 0. So we have a few things here. We have the general curvature of our sine function, looking like so, which continues out infinitely in the positive x and the negative x ranges, domains, such that our domain is -infinity to infinity. Range, well, the highest range we get to is +1. The lowest range we get to is -1. So our range is going to be -1 to 1. And yeah, that's about it. We went one rotation around the circle. So this is one period. Which is the same as basically 2 pi. From 0 to 2 pi, one rotation. And that's about it so far. For cosine, well, cosines were the x-coordinates of the unit circle. So if we take a look at our graph, keep in mind that we're still going off of our 0 pi to 2 pi, with our pi in the middle, pi over 2, and 3 pi over 2. We're now looking for our x-coordinates. At 0, that's going to be 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, 2 pi, 1. Giving us a slightly different curve, but a curve nonetheless. This curve will also continue out infinitely in the positive and negative x directions. So our domain is still -infinity to infinity. Range, our lowest value is -1. Our highest value is +1. So our range is still going to be -1 to 1. And period, we're still doing a one rotation around our circle. So one period of 2 pi radians. Now with any graph that we've done in the past, we've done transformations. So let's review transformations real quick. And we've done transformations before. If you need refreshers, there is a refresher on transformations in the previous course's algebra folder. But functionally, transformations follow a general idea that the a values in our transformations refer to the vertical stretches. Our b values refer to the horizontal stretches. Our c values, horizontal shifts. And our d values, vertical shifts. We should also keep a very important concept in mind, that the x's lie. Or, since it's so close to Valentine's Day, maybe you might want to think about it in terms of the x's lie. Either or, it works. But the idea that for things that are directly involved on our variable, on our independent variable, that big numbers for our stretches usually mean compressions and vice versa, whereas plus signs and minus signs are essentially flipped for our shifts. We're going to have the same general idea for trig transformations. We still have our A, B, C, and D, and we're using slightly different terms to talk about them, but generally it's the same idea. Our A is now known as our amplitude. And the amplitude is such that in a graph, our amplitude is essentially going to be the distance between the highest part and the midway point to the lowest point, or half the distance from the highest to the bottom. Our period is going to be our rotation. How long does it take to go through one rotation? In our parent functions, our period was 2 pi. We'll be talking about those kinds of stretches tomorrow. Our c value is now known as a phase shift, but it still follows the general idea that our x's lie in that x minus c moves things to the right, whereas x plus c will move things to the left. And then lastly, our d is still just our vertical shift. So instead of a vertical stretch, horizontal shift, and vertical shift, we now have amplitude, period, phase shift, and vertical shift. But the general concepts are exactly the same as every other transformation we've done in this course or you've done in previous courses. Let's take a look at some sample problems. Firstly, we want to look at y equals 2 sine theta. To start this off, we're going to draw out our parent function of sine theta so we can see whereabouts this, how this relates to it. Sine theta, well, that's going to be 0, up there at 1, down there at 0, down there at -1, down there at 0. Connecting our dots, we get our sine function. But now we want to take our sine function and we want to multiply that by 2. So at 0, the sine of 0 is 0. 0 times 2 is still 0. At pi over 2, our sine is 1. 1 times 2 is 2. At pi, we have another 0. At 3 pi over 2, we have a sine of -1. -1 times 2 is -2. And at 2 pi, we have another 0. So if we connect these dots, we should see that we still have the general shape of our sine curve, but now it's a little stretched out in the vertical direction. So our domain is still going to be negative infinity to infinity. The range, our lowest y value is negative 2. Our highest y value is positive 2. Brackets on both. Amplitude, that's going to be the distance from our highest point or lowest point to our midline. So that's going to be 2 and 2. So amplitude of 2. Period. This is still just one rotation. We're going from 0 to 2 pi. Phase shift, none. Vertical shift, none. All right, now let's take a look at vertical shifts. So once more, we're going to start off by doing our basic parent function. Because I'm shifting this one upwards, I'm actually making this a little smaller to begin with. We're going to go with ones. So 1, 2, 3, 4. Connect those dots for our sine function. Now we're going to shift everything up by 2 units because we have this nice little plus 2. So at our sine of 0 is 0 plus 2 gives me 2. This 1 becomes a 3. This 0 becomes a 2. That minus 1 becomes a positive 1. And then we have another 0 there. Connect our dots. Put our arrows on the end. So our domain here is still negative infinity to infinity. Our range, the lowest value we tend to hit is this minus 1 over here. Highest value is at 3. So our range is minus 1, comma, sorry, not minus 1, positive 1 to 3. Our amplitude is going to be 1 because given the midline that is here, our highest point is 1 unit above, our lowest point is 1 unit below. Period is still going to be 2 pi. Phase shift, none. Vertical slide, up 2. That, folks, is the completion of today's notes. We will have some more practice problems tomorrow, as well as an assignment for you. As always, please ask questions if you're getting stuck.